We follow the same tactic that we've done for the 25 ml alico. So, the number of moles of EDTA, we now relate it to the amount of nickel that was formed from our equation above. And since it's not the nickel that we're interested in, but rather the bromide and the bromate, we can now write the following. So plugging it into our calculator, we'll be able to get a total of 0.92 millimoles of silver bromide from the bromide ion originally present and the converted bromate that was turned into bromide. So that's 0.92 millimoles present in 10 ml of the alico. We get the quotient of the two as well. And so now, if we compare in the first 25 ml alico, AgBr is formed from the bromide alone. While in here, this 0.92 millimoles of silver bromide, it came from both the bromide and the silver bromate. So now what we want to do is we want to subtract that amount when the two of them are present minus that amount in which only one was present. So that's 0.92 all over 10 minus 1.12 over 25 that we got earlier. And so we're able to compute just how much bromate ion was present for every ml of the alico. Now this is the second thing that we're after. So we also have to take note of this one as well. So now that we know how many moles of bromide there is and how many millimoles of bromate there is for every ml, we now take note. Originally, there was a total of 250 ml. So this amount over here, we multiply it by 250. Same with the other value that we got on the previous page. And that's how we're able to compute the mass of our compound that we're looking for, which is first sodium bromide. So from the previous page, we have 0.045 millimoles of bromide for every ml multiplied by the total volume. And via your stoichiometric factor, you'll get, just by looking at the chemical formula, 1 millimole of sodium bromide present contains 1 millimole of bromide. This one in here is the molar mass of the sodium bromide. And so we're able to get this value right here. Now, since in this problem, we're still interested to know the percent composition of our mixture, we divide the mass of the sodium bromide by the total mass of the sample. Multiply it by 100% to get the percent of sodium bromide. So from my computation, this is 31.48%. Now you can do a similar computation to this one at home. Simply replace the amount or the moles of the bromide with the moles of bromate. And as well, the molar mass of the sodium bromate could be replaced over here. You should be able to get a percent sodium bromate composition of 48.57%.